so I think that'll work. Okay, the x of the vertex, if you want to write that, x of the vertex, and then axis of symmetry, I'm going to go ahead and write it. There is a couple of cases where it does help you. And it is x equals the negative b over 2a, remember in standard form, and then your x-intercepts can also be called zeros, and we wrote it on the other page that there can be found by factoring, they can be found by doing quadratic formula. I'm just going to write it like I did in second block. And then I want to give you what's called the standard, and I'm sure this is straight out of a physics book, the standard projectile function. And it's going to relate time and height. And time is your independent variable. That's the one that determines, like, if I give you the time, then you can tell me the height. You know, that's the one that's going to affect the other one. So it's h of t, and I'll address all of that with you, which I think will make this easier. And the way it's generated is 1/2 g t squared, there's your quadratic, plus v sub 0 t plus h sub 0. Now, in times past, I've had them generate the equation, which it's easy to do, but I generated it for you in your classwork. The ACT would at least give you this. I think they would probably give you the equation, but just to kind of give you the format, G is going to be your gravitational pull. Oh, I just wrote pull of gravity here. And gravity is causing the object to slow down. Now, and we're not watching its path. We're actually looking at its time related to the height. And it's hard to, sometimes you think it's the path of it. But, you know, I can throw an object straight up, and if the wind's not blowing, it's going to come straight back down. But if you look at the time graph to the height, you know, as the time goes on, 1 second, 2 seconds, the height of the object is changing. So the height, the graph is still going to look like a parabola whether the object takes a path of a parabola, simply because the gravity is going to pull it back down. And the gravity is, it's feet per second square. It's feet per second. And it's the idea that it is speeding up or slowing down every second, 32 feet per second. It's called the acceleration. But all this is going to be given to you. I'm just trying to justify what it is. Acceleration due to gravity on Earth. Now we're going to do it, and it's negative 32 because it's pulling you down. It's negative 32 feet per second, or you can say per second squared. And then I didn't give this to them, but it's in meters per second. It's negative 9.8 meters per second. I told them, but I didn't write it down. That's probably what you would see in a science class. I don't know about the ACT. That doesn't look like it's focused to me. That's better, maybe. Okay, see if that helps. And then what else do we need to talk about? Okay, v sub 0 is its initial velocity. Now, think about that. If I go to the top of a building, the building out here, and I hold an object out, and I just drop it, then its initial velocity is 0. I'm holding it still, I drop it. If I throw the object, especially throw it up and then back down, then that is going to be the initial velocity is whatever speed I'm throwing it. The speed that the rocket, we're going to look at a little toy rocket, and it's going to shoot it. Throwing a baseball, throwing whatever, you know, what pulls it back to Earth is the pull of gravity. I've seen problems you can get as involved as you want to. It gives you different gravity because on the moon, you know, it's not as much. Mars, some of them are stronger than it is on Earth, and some of them aren't. So that's all where those come from. And then h sub 0 is its initial height. The little rocket we're going to do in just a few minutes would start on the ground, the person jumping off the cliff is going to start up on a cliff. Depends on if a person's throwing something, it depends on how specific you want to be. You know, if I'm going to throw an object, 2 meters, 1.5 meters, whatever, or ever how many feet it is, it's kind of, based on how much you want to calculate, how specific you want to be. We don't get too crazy on it. And let's see if there's anything else I need to tell you. Okay, let's go down and let's draw just a generic graph. So I'm going to draw my x-axis down about 5 or 6 lines because we need to write a little bit under it. And we'll draw our vertical axis. And our x-axis is time in seconds. That's this axis. 0 seconds, 1, 2, 3. Now you have negatives back here, but we don't have negative time. And somebody asked in one of the classes last week about domain. Does domain always going to be all real numbers? Not on these word problems. I'll just mention it kind of casually to you in just a second. And then the y-axis is our height, and it will be in feet. And what else do you need to know? Think about it just as a t-table, where t is your x and h is your y. They'll either give us the height and ask for the time, or they'll give us the time and ask for the h. I mean, that's pretty much the arithmetic that you're doing. If I draw my graph just as and again, this is time related, it's hard because we tend to see it, and sometimes I even say it, that it looks like it's the path of the object. Parametric equations, which are actually on your calculator, if you, you can go in there and change the mode of it, and probably that would be pre-cal, maybe somewhere in there, and you could literally see the path of the object, which is kind of neat. Now, this point right here, if the object starts on the ground, or whether it does or doesn't, this one is the origin, and it's the time. See, order pairs, time comes first. So this is actually 0, 0, which means at 0 seconds, you are at 0 feet. That's where the object is. Then, what's this one over here? What's going on over here in terms of an ordered pair? Well, one of them's got to be 0. Which one's going to be 0? Is the x 0 over here? Now, x is 0. Remember, everything on your y-axis, x is 0. The y is 0. So what does that mean? That means it has a height of 0 feet. That's because it's done what? This is when it hits the ground, hits the water, whatever it's choosing to do, whatever we're choosing to do. And so at 0 feet, and then whatever the time is at that. And they'll say, here's the way they say it. What time, the first one, what time did Jason hit the water? What time did the object hit the ground? Something like that. And then up here, we know it better as the vertex. But what is it literally in terms of time and height? Think about it. You've got to order pair, time and height. Now, what is this going to be? Well, think about your y-axis. And it's kind of related to range, because whatever this is, say it's 100 feet or 500 feet, whatever, it's going to be, is that the highest the object's going to go, height-wise? If you line it up, yes. So it's going to be the maximum height, and then t is the time at that height. Now, if the object is starting on the ground and ending on the ground, and I barely had time to mention this last block, but that axis of symmetry is nice because you've got points that match up with each other, which is kind of nice as you're doing it. Okay, I think that's all you need to know. I think we're ready.